Today I'm going to introduce the SMC Gripper with ME3. The SMC Gripper has a stepping motor with incremental encoder on the shaft. As it rotates, it closes or pinches the gripper. And I'm going to try to prevent this from pinching my fingers. So we have B&B Electronics USB to serial adapter, serial cable connected. I've got 24 volt power supply and earth connected. So the mechanics of the gripper, this is the closed area here, fully closed. There's a shaft down the middle, which you can manually rotate it to open and close the gripper. There's a stepping motor with incremental encoder feedback, and the rest of the mechanical mechanism. The cables have ground and plus 5 volts for the encoder, A naught, B naught for the feedback, twisted, shielded, which connects to the feedback connector on the ME3, and then the motor power wires. And we can see the data for the motor: 1.8 degree stepping motor, 0.35 amps continuous inductance resistance. All the specifications for the motor were provided. And the feedback device, 800 pulses per rev, 5 volts at 500 milliamps. So we can see that we're configured with a stepper rotary with incremental encoder running in servo mode. And we're in a position mode, software programmed. From the motor data, we can see it's 200 line or 800 pulses per rev and 0.35 amps continuous inductance resistance, rated torque. I like to set the microsteps equal to the number of counts per rev. It's just easier to understand. You could set it to 10 times more if you wanted. That's fine. We get peak and continuous current limits, current loop tuning. In a servo mode, we have a velocity loop that gets tuned and a safe limit speed. And in position mode, we can check out the position loop gains and the feed-forward terms and the trajectory values. So what we're going to do first is to home to a hard stop. I've tested this out, which will, well, actually it'll close in on, oh, amplifier is disabled. Now let's enable it with the enable switch. So checking the control panel, phase not initialized. Enabling the drive, phase initialized. Now we can home it. We've enabled the drive, it initialized, so let's home it. And so to home, we just close to a hard stop and then back up a little bit. So homing is complete. With the CME2 scope, we can take a look at, it's down here in the tray in Windows, previously had it open. We can take a look at the profile velocity for the C-axis. I have a 3-axis ME3. Following error, actual current in motion. I can make an absolute move to 0 or an absolute move open. So let me open it. So with the gripper open, I'm going to insert a rubber stopper, and I'm going to close in on it by going to 0. Of course, we'll never reach 0 because we'll be squeezing the rubber gripper into the current limit. So we have a ramp up to speed from that position. We can go a little faster. Let's try 400. So I'm going to pull away from the stopper. So I've opened it up a bit. Easy to install and remove. And then I'm going to make a move to 0. And we're interested in the profile velocity. It's accelerate, run, decelerate, stop. And after a little bit of time, we've hit the current limit of 0.35 amps. So sometimes in a gripper, you want to prevent pinching. So we can lower this. We can basically cut it in half. Normally you just lower the peak current over the serial port or from the CVM program or from an input. So cutting this in half should give us a little less current and not pinch so hard. So I'll back away. So coming out of a current limit, we've backed off, and then going back into, now I'm pinching, and I've got a steady state following error, but my current is limited, so the force of the pinch is limited. So I'm back at it again, and we're going to try to use the serial port to change the current and the control panel to jog. One thing I've noticed is that we're on axis C of the 3-axis drive, and so we'll have to take that into consideration when we try to get the values from the drive. So the peak current limit, get from RAM 0x21. This is the value from the A axis. It's 300. The last we left, the C axis dot C space, is 20. So that would be 0.2 amps. So we can set 0x21 to 0.1 amps, which is 10. That's the peak current, so that overrides. So that's the limit of the current, 0.1 amps. So if I go in the positive direction, I'll be closing on it up to 0.1 amps. And then when I back away, the current will come back down. So we'll see how easy it is to remove when we're fully closed on it. So 0.1 amp. It lets go and then continues to close. Okay, thanks for watching SMC Gripper with a Copley drive.